Have you ever looked up at the stars and wondered about the vastness of it all? The silent, glittering expanse that stretches on forever. It feels so still, so unchanging. But what if I told you that it's not? What if I told you that something we take for granted, something we think is constant for everyone, everywhere, is actually flexible? I'm talking about time itself. Time is not the same for everyone. It ticks at different speeds depending on where you are and how fast you are moving. This idea is one of the most mind-bending in all of science. It changes everything we thought we knew about our universe. This strange behavior of time is called time dilation. It's a big phrase for a simple yet profound idea. It means time can stretch and shrink. Imagine a clock in your kitchen. It ticks away the seconds, minutes, and hours with perfect regularity. Now imagine another clock, but this one is on a rocket ship, speeding through space. According to the universe's hidden rules, the clock on the rocket will tick slower than the one in your kitchen. For the astronaut on board, time is passing more slowly. This isn't science fiction, it's real, and it has been measured. It's a fundamental part of how our cosmos works. Why should we care about this? Well, it's not just a curious fact for scientists to ponder. It has real consequences for our modern world. Think about the satellites that orbit our planet. They provide us with GPS. To understand this better, let's think about a famous thought experiment. It's called the twin paradox. Imagine two identical twins. Let's call them Anna and Ben. They're both the same age, down to the very second. Albert Einstein. In the early 20th century, Einstein turned our understanding of the universe upside down. He proposed that space and time are not separate things. Instead, they are woven together into a single, four-dimensional fabric. He called this fabric Spacetime. Think of it like a giant, stretchy sheet of rubber. Everything in the universe, from you and me, the first, is special relativity, which he published in 1905. This part deals with speed. It says that the speed of light in a vacuum. The second part of his theory is general relativity, which came about 10 years later. This part added gravity into the mix. Einstein realized that massive objects, but what about the real world? Does time dilation actually happen to real people? The answer is a resounding yes. Every single astronaut who has ever traveled to space has experienced time dilation. Consider the astronauts who went to the moon during the Apollo missions. They traveled faster than any humans had before, reaching speeds of nearly 40,000 kilometers per hour as they returned to Earth. For their entire mission, they were moving much faster than anyone on the ground. According to Einstein's theory of special relativity, their clocks should have been ticking just a little bit slower. The answer lies in atomic clocks. These are the most accurate timekeeping devices ever created by humanity. Instead, they use the incredibly regular and predictable vibrations of atoms, specifically atoms like cesium. One of the most famous was the Hayflick-Keating experiment in 1971. Scientists put several atomic clocks on commercial aeroplanes and flew them around the world, once eastward and once westward. The GPS network consists of a constellation of satellites orbiting the Earth. There are more than 30 of them, at an altitude of about 20,000 kilometers. To figure out your exact location, your phone or GPS receiver needs to listen for signals from at least 4 of these satellites. Each signal contains, so if we didn't correct for this 38 microsecond difference, the system's navigational errors would build up at a rate of more than 10 kilometers every day. Within hours, beyond our daily navigation, the principles of time dilation are absolutely essential for exploring the universe. When we send robotic probes on long journeys to distant planets and beyond, they become our eyes and ears in the cosmos. Missions like the Voyager probes, which have now left our solar system, it's no longer just a curious theory, but honestly a potential tool for our future voyages into the great cosmic ocean. Imagine a mission to our nearest stellar neighbor, Proxima Centauri, which is just over 4 light-years away. Even with our most advanced current technology, such a journey would take tens of thousands of years. But if we could build a starship capable of traveling at a significant fraction of the speed of light, say 99% of it, the story changes completely. For the crew on board, time would slow down dramatically. They would return to a home they no longer recognize, a world where everyone they ever knew has long since passed away. They would be strangers in their own land, historical artifacts from a distant past. It has fundamentally altered our perspective on our place in the universe. For millennia, we believed we were at the center of everything, living under a single universal clock. Now we know that this is not true. We live on a small planet, in a quiet corner of a vast galaxy, where even the passage of time is not a constant. This realization is a humbling one. Understanding that time is relative also connects us to the cosmos in a very intimate way. The very atoms in our bodies, the biological clocks that govern our lives, are subject to these universal laws. When an astronaut travels at high speed, this shift in perspective is perhaps one of the most important gifts of science. It moves us away from a self-centered view of the world and towards a more cosmic one. It reminds us that our human experience is just one of countless possibilities. In the end, the story of time dilation is a story about the human adventure. It is a testament to our relentless drive to understand the world around us, no matter how counterintuitive the truth may be. From Einstein's imaginative thought experiments, the journey is far from over. Our understanding of space-time is still incomplete. For the next generation of scientists, time dilation will be a fundamental part of their toolkit. Ultimately, what the science of time dilation teaches us is that the universe is full of wonder. It shows us that reality is a rich and layered tapestry, and we have only just begun to explore its intricate patterns. It reminds us that our common sense view of the world is just a small window onto a much larger reality. As we continue our human adventure, reaching further into space and deeper into the mysteries of the cosmos, we carry this knowledge with us. It is a source of humility, a spark for our imagination, and a constant invitation to look up at the stars and wonder.